So here we have this. We are taking V to be the vector space of all mapping from real numbers to real numbers. We are taking maps from real numbers to real numbers, and we take two subset. Means V1 is a subset of even functions and V2 is the subset of odd functions. So we have to show that V is the direct sub of all of the subspace V1 and V2. So first of all, let us show that V1 and V2 are subspace of V. Okay, so I take two elements from V. So the elements of V are functions. So I take two functions from V1, and I to take two scalars from the field. The field is real number, so I take alpha beta from belongs to R. Okay, so I take this. So I have to check this one. If it is even, this is an even function. I have to check that the linear combination is an even function or not. If it is an even function, then this linear combination will belongs to V1. So I took this, I take minus x. So by the definition of function, this minus x will be separated to each. So we get here. Then this alpha f1 minus x is same as alpha of f1 applied on minus x. Same way here also, beta f2 applied on minus x. But f1 belongs to v1, so f of minus x is what? Fx. It is an even function. f1 is an even function as well as f2 is an even function. So this f1 minus x will be equal to f1x. Same way f2 minus x will be equal to f2x. So we get this. So this can be written as alpha f1 applied on x plus beta f2 applied on x. So that is same, you can take x out. So we get alpha f1 plus beta f2 applied on x. So if I take alpha f1 plus beta f2 applied on minus x, I got alpha f1 plus beta f2 applied on x. So that shows that this function is an even function. So that means that this will belongs to v1. So this belongs to v1, hence v1 is a subspace of v. Okay, now we'll try to show v2 is a subspace. So I take two elements here. There I took two functions. So these are odd function, and I take two scalars from the field. Now I have to show that this linear combination is an odd function. So I take this way, minus x. So we alpha f1 minus x plus beta f2 minus x. So this is alpha f1 applied on minus x plus beta f2 applied on minus x. So this can be written as alpha f1 applied on minus x plus beta f2 applied on minus x. f1 minus x, this is an odd function, so this will be equal to minus f1x. Same way, this is also an odd function, this will be equal to minus f2x. So from here, I can take minus common, so I get here alpha f1 applied on x plus beta f2 applied on x. X I can take out, so we get minus alpha f1 plus beta f2 applied on x. So here I took alpha f1 plus beta f2 applied on minus x. I got minus of alpha f1 plus beta f2 applied on x. So this shows that this linear combination function, this function is an odd function. So this will belongs to v2. So this belongs to v2. Hence v2 is a subspace of v. Okay. Now we want to show it is a direct sum. V is the direct sum of v1 and v2. So I take one element in v. Then we can find unique element f1 in v1 and an f2 in v2 such that f is equal to f1 plus f2. Okay, so this is written uniquely. Now if we have to just show that the intersection consists of only zero function, so I take one function in intersection of v1 and v2, then this f3 will belongs to v1 as well as f3 will belongs to v2. So we have this. If f3 belongs to v1, then f3 is an even function. If f3 belongs to v2, then it is an odd function. At the same time, any function cannot be even as well as odd. This is only possible if f3 is equal to 0 function. So here we have f3 should be a 0 function. So we took an arbitrary element in the intersection and we got that that arbitrary element is 0 function. So the intersection consists of only 0 function. Okay, so the intersection consists of only 0 function. Hence v can be written as v1 direct sum v2. That is the internal direct sum. We are talking about the internal direct sum. Let us do one more question of this type. So here we are taking u to be xy belongs to R2, where y is equal to 2x, and w is this, where y is equal to 3x. then we have to show that V is U plus direct sum of W, where V is equal to R2, a vector space over the field R. Okay, so I'm taking first of all I'll try to show that U and V are U and W are subspace. So I take two elements in U, okay, and alpha beta belongs to R. So since there are two, I take two elements in U. Since x1 comma y1 belongs to U, y1 will be equal to 2x1 and y2 will be equal to 2x2. Okay, so I'm putting in place of y1 as 2x1, in place of y2 I put as 2x2. Then I multiply this alpha inside, I get this. Okay, so I get this. So I'll add coordinate y, so I get alpha x1 plus beta x2, 2 alpha. So I can take common 2 here. Now if we look here, this alpha is from the field, x1 is also from real numbers. Okay, beta is also a real number, x2 is also a real number. So this is a real number, product of two real number is a real number. And in the same way here also, sum of two real number is again a real number. So this is a real number. Okay, so this is a real number and this is also a real number. So it is of this form, it is of the type of this, it's this type. And so this belongs to U. So this belongs to U. So that shows that U is a subspace of R2, which is equal to V. Okay. In the same way, I'll take two elements in W and I take two scalars in the field that is real numbers. So since this x1, y1 belongs to W, y1 will be equal to 3x1 and y2 also will be equal to 3x2. So we'll put here 3x1 and 3x2. So I get 3 alpha x1, 3 beta x2. I'll add coordinate y, so I get this alpha x1 plus beta x2, 3. I will take common. So this, in the same way like as above, what I have explained you, this will belongs to the real number as well as this belongs to the real number. So it is of the type of elements which belongs to W. So that's why this element will belongs to W. So we have shown that the linear combination belongs to W. So therefore W is a subspace. Okay, so we got W to be a subspace here of R2. We got W is a subspace of R2. Now I take any element in V, then this can be that exists unique element U in U and W in W, such that this can be written as this. Okay, this can be written as this. Now my aim is only to show that the intersection of these two consists of only 0 element. So I took one general element in this intersection. So this element will belongs to U as well as W. So I took, so an element belonging in U means y is equal to 2x. An element belonging in W, that means y is equal to 3x. So we get y equal to 3x here. Here we got y equal to 2x. Both are y. So these two should be equal. So we get 2x equal to 3x. So we get here 3x minus 2x is equal to 0. So that shows that x is 0. So we got x to be 0. Now you put this x in any of this, we get y to be 0. Anyway, we'll get y to be 0. So I'm taking a coordinate, I take an element x and y. So I got x to be 0, y is also 0. So I took a general element, I got that general element should be 0. So this U intersection W consists of only 0 element. Okay. So here it consists of U intersection W consists of only 0 element. So since it consists of only 0 element, hence V can be written as the direct sum, internal direct sum of U and W. Thank you.